In the natural world, no new gold is being created on Earth today. If you buy a freshly minted coin or a brand new wedding ring, the atoms making up that metal are billions of years old. They existed long before our planet was even formed. The gold we wear, hoard, and use in our technology is entirely second-hand. But if Earth didn't create this material, where did it come from? And how did a scattered cloud of cosmic debris end up buried deep within the Earth's crust, only to become the foundation of human economies and modern electronics? When we think of the creation of elements, we usually look to the stars, but standard stars, even our own sun, have a hidden limitation. Their nuclear furnaces simply do not possess the sheer power required to forge an element as heavy and dense as gold. Squeezing atoms together to build something this massive demands a much more extreme environment. If normal stars cannot manufacture gold, what can? Modern astrophysics points to one of the primary sites where gold is forged, the collision of neutron stars. When these ultra-dense collapsed stars smash into each other, they generate a chaotic, high-energy environment that rapidly forges gold and other heavy elements. This means the gold we rely on today began as a scattered cloud of heavy element debris, drifting as dust through the frozen vacuum of space for eons before our solar system even existed. But this cosmic origin story introduces a major geological puzzle. As the early Earth formed from a swirling cloud of gas and dust, it captured a portion of this gold. However, during its infancy, the planet was a churning sphere of molten rock. Gold is an exceptionally heavy element. Following the laws of gravity, most of the early Earth's heavy metal budget would have sunk deep toward the molten iron core, locking it away thousands of miles beneath our feet. By all logic, very little gold should have remained in the Earth's crust. We shouldn't be able to find it near the surface at all. The leading explanation for this mystery lies in a heavy celestial bombardment. Long after the Earth's core had formed, the young planet was battered by a relentless storm of meteorites. These rocky visitors carried fresh payloads of heavy elements, enriching the Earth's crust with gold. Every time we pull an ounce of gold from a mine, we are unearthing material originally delivered from space, long after the planet had already taken shape. After lying dormant in the crust for billions of years, humanity finally dug it up. From the Egyptians and the Romans to the Han Dynasty and the Incas, isolated civilizations across the globe independently developed an obsession with the exact same yellow metal. But its appeal wasn't just its color. The true secret to gold's historical dominance and its modern utility lies in its atomic structure. Gold is almost completely inert. It does not react with oxygen or water. It doesn't rust, it doesn't tarnish, and it doesn't degrade. This chemical stubbornness creates a fascinating reality. A gold nugget mined in ancient Egypt could have been melted down to forge a pharaoh's burial mask. Centuries later, that exact same metal could have been looted, melted again, and stamped into a Roman coin. During the Renaissance, it could have been reworked into a nobleman's necklace, and today, those very same indestructible atoms might be microscopic components sitting inside the circuit board of the smartphone you are using right now. Because gold does not degrade, it simply changes shape and changes hands. Those same atoms have continued to circulate throughout human history. Before a single atom of gold reaches your finger or the microchips powering global communications, it has survived an incomprehensible journey. It was forged in the violent collision of neutron stars, drifted through the silent void of space, and endured the extreme heat of a young forming planet. It was buried under tectonic plates and witnessed the rise and fall of countless human civilizations. We assign value to gold because it's rare and beautiful, but its true significance lies in its permanence. It was here before the first cities, before agriculture, and before the first humans walked the earth. It will remain long after our modern infrastructure has turned to dust. Ultimately, every atom of gold on this planet is a cosmic hand-me-down. We don't actually own it. We're simply the latest custodians on a very long list, holding on to a piece of the universe until it is time to pass it on.